On this video, we're going to talk about double angle identities. So we have sine to theta equals 2 sine theta cosine theta. And cosine to theta equals cosine squared theta minus sine squared theta. And you have the other two for cosine to theta. And tangent to theta is 2 tangent theta over 1 minus tangent squared theta. Now let's kind of take a look at where 2 sine to theta came from. Do you remember from sum and difference identities? The sine of quantity alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. Well, in this case, sine to theta is just theta plus theta. The theta plus theta is 2 theta. Now, your alpha is theta and your beta is theta. So all you got to do is plug it in. You get sine theta cosine theta plus cosine theta sine theta. Now, notice these two are the same. It's just that this is in reverse order. So it ends up with 2 sine theta cosine theta. That's how you get sine 2 theta is 2 sine theta cosine theta. Now let's talk about cosine 2 theta. Cosine 2 theta is same thing as cosine of quantity theta plus theta. Again, do you remember cosine of quantity alpha plus beta? That is cosine alpha cosine beta minus sine alpha sine beta. So again, alpha is theta and beta is theta. So when you plug it in, you'll end up with cosine theta cosine theta minus sine theta sine theta. So you end up with cosine squared theta minus sine squared theta. That's how they got this identity right there. Now what about the other two? Well, do you remember Pythagorean identity? Sine squared theta plus cosine squared theta is 1. So what is sine squared theta? That equals to 1 minus cosine squared theta. Now, when you substitute, instead of sine squared theta, when you substitute 1 minus cosine squared theta, guess what? You will end up with this identity right there. And I think by now, you should know how to get this identity. And using similar method, you will know that tangent of 2 theta is 2 tangent theta all over 1 minus tangent squared theta. Let's take a look at example. We have given that cosine theta is 3 over 5. And theta has a restriction. It's from 0 to pi over 2, which means that theta is in the first quadrant. Okay? Now we have to find sine 2 theta, cosine 2 theta, and tangent 2 theta. Alright, so since cosine theta is 3 over 5, that means this value right here is 3, and that's going to be 5. Remember, it's x over r. So what is the y value then? Well, using Pythagorean theorem, you know that it's going to be 4. So based on this triangle, you know that cosine theta is 3 over 5, and sine theta will be 4 over 5. What about tangent theta? Tangent theta is y over x, so 4 over 3. Now notice, we need to find sine 2 theta and cosine 2 theta, tangent 2 theta. These are cosine theta, sine theta, tangent theta. So what is sine 2 theta? Well, sine 2 theta is the same thing as 2 sine theta cosine theta. And what is our, and then it's just a matter of plugging in now. So 2 times sine theta is 4 over 5. And cosine theta is 3 over 5. So you end up with 24 over 25. That's the sine to theta. What about cosine to theta? Well, for cosine to theta, you have 3 options. So I'm just going to choose cosine squared theta minus sine squared theta. Okay? But if you want, you could choose any of the 3 options. So now you get quantity 3 over 5 square minus quantity 4 over 5 square. You end up with 9 over 25 minus 16 over 25, which is negative 7 over 25. And that's cosine to theta. Now what about tangent to theta? Tangent to theta, well, you know that you have an equation for tangent to theta, 2 tangent theta over 1 minus tangent squared theta. And you could plug in tangent theta for 4 over 3. You could do that too. But you know how I like to avoid using formulas? So notice tangent to theta is same thing as sine to theta over cosine to theta. And we found sine to theta and cosine to theta. So all you got to do is sine to theta, which is 24 over 25, divided by negative 7 over 25, which is, when you simplify this, 25 will cancel out. You get negative 24 over 7. And that's tangent to theta. Let's solve this equation. You have cosine to theta is negative sine squared theta. And notice you have a restriction on your theta. So cosine to theta is cosine squared theta minus sine squared theta equals negative sine squared theta. Now when you add sine squared theta to both sides, you get cosine squared theta is 0. And when you take the square root, you end up getting cosine theta is 0. Okay? Now cosine of what is 0? Well, that's when theta is pi over 2, when theta is 3 pi over 2. And those angles are within the restriction. So you have 2 solutions, pi over 2 and 3 pi over 2. Now, this is the way you solve it without the graphing calculator. And now you might want to solve this equation using graphing calculator. So again, you want to probably set this as your y1, set that as your y2, set your the domain from 0 to 2 pi, and then see where they intersect. And the x values where they intersect should be pi over 2 and 3 pi over 2. Let's take a look at last example. You have tangent to theta equals 2 tangent theta. So you know that tangent to theta is 2 tangent theta over 1 minus tangent squared theta. So now if you want to get rid of the denominator, you want to multiply both sides by 1 minus tangent squared theta, and you end up getting 2 tangent theta equals 2 tangent theta times the quantity 1 minus tangent squared theta. You need to be careful that you don't divide by the variables. Some of you will be tempted to divide both sides by tangent theta, but that's not mathematical, because when you do that, you might lose one of the answers. So now you want to distribute this. Okay, even though you cannot divide by everything by a variable, you may divide everything by a constant or numbers. So I like to divide everything by 2 to make the equation simpler. And then what I'm going to do is I'm going to move negative tangent cube theta to the other side. And subtract tangent theta both sides, you will get 0. So take the cube root of both sides, you will get tangent theta equals cube root of 0, which is 0. Now, tangent theta of what is 0? Well, if you don't recall right away, you could write it as tangent theta over cosine theta equals 0. And you know that fraction is 0 only when the numerator is 0. So when you sine theta equal to 0, well, that's when theta is 0, when theta is pi. Notice, sine of 2 pi is also 0, but look at the restriction. Our theta does not include 2 pi. It includes 0, but it does not include 2 pi. So we only have 2 solutions here, 0 and pi. Now, again, you might want to graph this as y1 and y2 and see where they intersect when the domain is from 0 to 2 pi. You have to know how to do these both without the calculator and with graphing calculator.